In this video, I'm going to teach you guys how to draw a chemical structure, and we're going to be using a antifungal agent as an example, which is amphotericin B. And amphotericin B is a polyheme derivative that is used as an antifungal agent under the class antibiotics. It was discovered by Vic Gold, Pagan, and Salt in the year 1956. Its mechanism of action is mentioned here. I actually made this for you guys to see it properly. It binds to the ergosterol that is present in the membrane of sensitive fungi and the interaction with these sterols on the cell membrane of this fungi. These reactions lead to an increase in the permeability of the membrane, allowing leakage of various small molecules such as intracellular, potassium, magnesium, salt, sugar, and metabolites. These are all the essential nutrients required by the fungi cell to keep functioning, and when they are all leaked out, that is, a leakage occurs, the fungi is going to die. So this is the properties and uses. This polyheme named amphotericin B is actually derived from a microorganism which is known Streptomyces nodosus. Yeah, it is an amphoteric compound and consists of several conjugated double bonds on internal ester, a free carboxyl group, and a glycoside side chain. I'm going to show you everything in this structure because we're going to be drawing this structure today, and you can apply the same method with other chemical structures you plan to draw or you intend to draw. So do pause this video and read what is on this presentation. Thank you so much for doing that. Okay, if you are done, very good. So now I'm going to type amphotericin B because I already designed the structure already. But in this video, I'm going to design from scratch again for you guys to see the whole process and the whole procedure and the whole tools used. However, we're using a software named ChemSketch. It is absolutely free. You don't need to pay anything for it. So I'm going to add the link of ChemSketch in the description below for you guys to download it without paying anything, for free, absolutely free. So this is the compound we're going to be drawing the structure today, which is amphotericin B. So as you can see, this is the structure I've already drawn. I drew this structure a few minutes ago before starting this video. I'm going to start again. I just want you to see the structure. Please take a screenshot right here. Note everything on this structure. So I want to enlighten you guys a little bit more about this structure. Okay, the first thing you're going to realize is this benzene ring, and these carbons have its own function. Every number of the carbon have a compound a functional groups that you must put on it. On these carbons, there is an hydroxy groups attached. In amphotericin B, carbon 2, 4, 8, 10, and 16 have hydroxy groups attached to them. As you can see, this is carbon 2, 1, 2, 4, 8, 10, and 16. So another thing I need you to take note is on carbon 5, there's also an hydroxy group right here. So if you haven't read about amphotericin B at all and you want to draw the structure, I will recommend you to read about it for you to understand what I'm saying better. So that this video is going to be just a revision on how you can draw the structure successfully. So another thing I need you guys to take note is on carbon 13 and 12, carbon 12 and 13, there's double bond O. There's a bond with oxygen there. So I need you to take note of that as well. On carbon 14, 15, and 17, there's methyl group substitute present, as you can see. And the difference between amphotericin B structure and nystatin structure is polyheme polyenes that are present. 1, 2, 3, 4, 5, 6, 7. There's 7 polyenes in amphotericin B, while in nystatin is only 6. The polyene of 22 is absent. Okay, very good. So I will start drawing this structure now. Okay, I want you guys to take note of also this section right here. This is carbon 32. This is carbon 32. I'll show you the numbering, how to number it, and how to identify which number or what compound you should attach to that carbon. So this number right here is 32, and pyrenyl ring is attached. This is a pyrenyl ring right here. How to draw it, I'm going to teach you how. Relax and stay tuned. Let's dive right in immediately. So I'm going to start afresh right now. Okay, as you can see, we're going to start absolutely afresh from the beginning. I want you guys to please pay attention. Sorry about that. So the first thing first is to open a new page afresh. You can start afresh. So the next thing you're going to do is you're going to, okay, yeah, I want to show you the tools. These are all the tools right here. Draw normal, draw continuous. There are other tools as well here, which you can also use. Okay, these tools are not currently active because the compound is not, I haven't started drawing the structures. But if you want to, I will recommend you to learn all these tools, know their names and their functions. I will show you how to use them in this video. So first thing, you're going to click on this tool right here, draw normal. You're going to pick a benzene ring, okay, a cyclohexane ring actually, because you want to ensure you draw it properly. So you're going to pick a cyclohexane ring. Okay, please hold on guys, I have to restart again. So guys, I just rectified the issue I'm having earlier. So you're gonna pick this ring at first. You're gonna bring it out right here. Okay, I'll just pick just one. Okay, as you can see, all these other tools are active now. The moment I picked this cyclohexane ring. So we're gonna start with cyclohexane at first. I want to delete all these errors so we can have a blank page with just this cyclohexane ring. So the next thing you're going to do is you're going to attach a OH with this cyclohexane. And you're going to click on this carbon. You're going to click on it one time so that it's not going to bring all the carbons out, other bonds with carbons out as well. So you're going to click on this as well. So the next thing you're going to do is also, you're going to add another one here, another body here. Also another one here. So how do you change this methyl substitutes to the compound that you want it to be, which is OH hydroxy group should be attached with here, COOH should be attached here, and this should be attached with carbon. So how do you achieve that? We can achieve that by simply clicking on this tool right here, this edit atom label tool. Once you click on it, you're going to click on the compound you want to change, and you're going to click, you're going to type OH. Okay, the best part about this is you can also change the font to any of the fonts you prefer, but I actually prefer Georgia, so I'm going to pick Georgia. I'm going to install immediately. As you can see, insert immediately. As you can see, it's changed automatically. So the next thing you're going to do again, you're going to repeat the same process based on the compound you are trying to draw its chemical structure, and you're going to follow the same procedure over and over again. So now we're done with that. So we want to move to the next part where we're going to also change this to hydroxy group. So we're going to click on this again and also OH, insert. So what else do we have to do now? We have to keep making this bond continuously. You just keep following, watch closely what I'm doing. You just keep doing this. You will still count it because the number of the carbon bonds is very essential. So I'm going to remove the ones that are not required, and I'm going to add the ones that are required. So I'm just doing this to save time and to ensure I'm able to explain properly. So I'm making this fast so that you guys can understand. So all these other bonds will be removed shortly because we don't need them for the compound we are currently drawing. So on the first carbon right here, there is no bond in amphotericin B. It's an empty bond, so you're going to keep it empty as well. So as you can see, it's empty now. This carbon have hydroxy group connected to it, and the second carbon, 1, 2. This carbon have hydroxy group connected to it as well. So add it once you're done adding it. Okay, the next thing is 3, carbon 4. This carbon 4 requires hydroxy group. So firstly, you're going to go back and click on this 2, click on OH, then you're going to click on this 2, you're going to click on OH, you're going to change it. You repeat this basic same process over and over again to be able to get the same result I got. So on this carbon, there is no bond present. But remember, I said earlier on carbon 5, hydroxy group is present in amphotericin B. So this bond right here, we're going to change it to OH. Okay. So give me a few more minutes to do that. Okay, this guy, we're going to change it to OH now. Great. So this is fourth carbon, this is the fifth carbon, this is sixth. Sixth carbon doesn't have any bond in amphotericin B. Seventh carbon also doesn't have any bond, but 10, okay, sorry, 5, 6, 7, 8. 8 carbon have hydroxy group and 10 carbon have hydroxy group because this is 9. So let's change that immediately. So guys, we're in 10th carbon now. 10, 11, 12. Okay, this is the 12th carbon. If you pay attention to the beginning of the video, I said 12th carbon have double bond hole, right? So this, we're going to convert this now. When you want to convert a sigma bond to a pi bond, you're going to double tap on it. If you don't know what a sigma and a pi bond means, a sigma bond is a basic single bond that is very strong, and when it is broken, it releases a lot of energy, or it takes a lot of energy to be broken. And when it is broken, it releases a lot of energy as well. While double bond, which is pi bond, is easily breakable and it releases less energy. So you're going to click on it twice. You're going to double tap on it to turn it to double bond, to turn it to triple bond, as much as you want based on the structure you're drawing. So you're going to change this to oxygen, just O. Okay. I'm going to click on insert. As you can see, it's OH now because this bond converted back to single bond. So I'm going to convert it back to double bond. Okay, excuse me, sorry. This is 10, 11, 12. Okay, this is 12. Okay, this is the compound. I need to change it. Sorry about that, guys. That's a glitch. I'll make sure that doesn't happen again. We'll change this now. This is a compound I need to change to O. Oxygen. Why this is 13. 13 require oxygen as well, based on the bonds that need to be present on amphotericin B structure. So right here, we're going to double tap, convert it to double bond. We're going to change this guy to OH. This bond to OH right here. Once that is done, this is 12, 13, 14. And as I said earlier at the beginning of the video, 14 have methyl substitute. So when we click on 14, this is the 14th carbon right here. If you're following, congratulations. So keep following so that you can actually understand how you can draw any structure successfully without making any mistake. Even if you make any mistake, it's part of the game. When you make the mistake, you rectify it immediately and ensure you don't make it again. So this is carbon 13, 14. As I said earlier, carbon 14 is attached to a substitute of methyl. So you're going to double click on carbon 14. You're going to click once, actually, not double click. So once you do that, you're going to click on the next carbon as well. Again, we're going to do the same thing again and again. So this is 14, carbon 14, carbon 15, and carbon 16 right here. So carbon 16, carbon 15 have methyl substitutes as well. So while carbon 16, if you remember where I was saying earlier, carbon 16 is attached with OH group, hydroxy group. So we're going to click on this, we're going to click on this OH, and we're going to click on insert. So once you're done inserting, then you're going to click on draw normal again. So we're done with carbon 16. Here's our carbon 17 right here. So this is, okay, sorry. This is our carbon, carbon 16, 17. And carbon 17 is also substituted with methyl as well. So you're going to leave it like this. And this compound, you will continue with this. So this is 17, carbon 18. And we want to make it, now we're going to start drawing the polyene. So how are you going to draw the polyene? Just stay tuned and keep watching. Do not skip any part of this video for you to understand every move I make by drawing these structures. So the reason I'm doing this is to make it faster, and it's actually fun to play around with this too because you want to learn. So the more you make mistakes, the more you learn how to use it much better. I was taught by my lecturer, and I'm here to teach you guys as well. So as you can see, I have made this this straight chain right here. So we're going to make all of these, we're going to make polyenes out of them. So how do I do that? Just follow the same procedure right now. Firstly, you make the chain so long, then you delete all the unnecessary bonds there and add the necessary ones that you require. Okay? So now we have this now, okay? So this is 18. On 18, we have a polyene as well, that is double bond. So we're going to add it there. This is carbon 18, carbon 19, carbon 20. Carbon 20 also have double bond as well. So we're going to add it. This is carbon 20, 21, 22, 22. Carbon 22 in cysteine polyene is not present. Take note of that if you are studying Amphotericin B and cysteine. So this is carbon 22. So 23, 24. I'm going to add a double bond right here. 25, 26. 26, you're going to add a double bond. Also 28. This is 27, carbon 27, carbon 28. We're going to add a double bond 29. And carbon 30. Okay. Carbon 30 is also have a polyene attached to its heat. So there's going to be a double bond. And you're going to go back here, click on this carbon as well. So this is carbon 30, carbon 31, and this is carbon 32. So, and this is carbon 33. So we want to connect this both together. Okay. So you're going to click on this two right here, lasso, on and off. So you're going to do it like that, just like that, okay? Just like that. Okay, sorry. I need to make sure it's done properly. So I will do it in a different way now. I just remembered something. So once I click on, finger. So it's already done automatically without me doing much. So as you can see, this bond is connected successfully. This is carbon 30, 31, carbon 31, carbon 32, carbon 33. So on carbon 32 is where we're going to attach pyrenyl ring. So how are we going to do that successfully? Just keep watching and stay tuned. Watch the video properly so you can also implement the same procedure while you are using ChemSketch. And it's also free, you don't need to pay for it. Other tools that could be used, I will add them in the description below. Do check it out and install all these free softwares. So you're going to click on carbon, you're going to click on it at once. And remember, you're going to change radical label. You're going to add a radical label because we want to add oxygen right here. You're going to click on whole. If it's not there as an option, you're going to type whole. And you're going to insert. So once you are done inserting, this will happen. And the next thing we're going to do is we need a cyclohexane again. So we're going to pick a cyclohexane right here. Once you pick it, you're going to drag and drop. So once you drag and drop, the next thing we're going to do is make underbond. So we're going to be using this draw continuous. We're going to be using this to draw continuous right now. So after that is done, want to ensure this bond connects. Sorry about that. Okay. I want to pick this bond carefully. Okay, good. Without changing the structure of the benzene, just ensure the cyclohexane remains the same way. Okay, good. So as you can see, we have made the pyrenyl ring right here. Pyrenyl ring has been formed. So now we have to add the substitute of the pyrenyl ring. The first substitute right here is methyl on carbon number 2. And we're going to add OH in this carbon. Sorry, on this carbon. And this, we're going to add NH2 primary amine. I'm going to add OH also, hydroxy group here as well. So we're going to use the same radical label. So click on this. We don't need to change this actually. This is methyl substitute. So we're going to change this OH to OH. We're going to insert, and this we're going to change it to NH2. NH2 is not here already, so I'm going to type it. And we're going to change the font to Georgia or any font you wish to use. It's absolutely free. You can pick it and use it. Okay, so this is the last part. We're going to add hydroxy group also insert. So guys, this is how you can draw any structure you wish to draw. Okay, and also how to label, right? You're going to add the name of this compound, Amphotericin B. Amphotericin B structure. Amphotericin B chemical structure. Amphotericin B chemical structure. So I'm just labeling this for you guys to know which compound we have been drawing so far. And I hope you all watched the video from the beginning for you to understand everything we are doing right now. And if you did, congratulations, you did it successfully. You are with me right from the beginning and to the end of the video. I really appreciate your time. I hope you learned something today. Please comment in the comment section below if you need any assistance or you're having any difficulty installing ChemSketch, and I will respond to you as soon as I can. Thank you so much for watching. See you in the next video. Cheers. Bye guys.